Welcome to Module 3, Advanced Math. Just like algebra, this topic also makes up 13 to 15 questions of the math section of the SAT, so it is the other larger topic that we'll be focusing on. In this module, we'll be working on 13 lessons, and we'll also be going through them in 3 different levels, just like we did in Module 2. So let's start with Lesson 1, Factoring quadratic and polynomial expressions. So before we factor, right, because factoring polynomials is sort of like dividing polynomials. It's breaking them apart. So thinking in terms of inverse operations, before we factor, let's multiply. So let's take a look at this question right here. Which of the following expressions is equivalent to negative 5x to the 4th power times the difference of 4x to the 4th power minus 2y. So what we're going to do is we're going to use the distributive property. We're going to take the outside term, which is negative 5x to the 4th power, and distribute it to each term inside our parentheses. So negative 5x to the 4th times 4x to the 4th. We multiply the coefficients, right? And since we have the same variable, we're going to keep our variable x, and we're just going to add the exponents. We're going to add 4 plus 4. So that gives us negative 20x to the 8th power. Now we're going to take negative 5x to the 4th power and multiply it by negative 2y. So again, we'll multiply our coefficients, negative 5 and negative 2. But notice how now we have x and y. So basically what's going to happen is x to the 4th power times y is just x to the 4th power times y. So we get plus 10x to the 4th power y. And that is choice B. Please pause this video and work on the Lesson 1, Level 1 problems in the workbook. Moving on to Level 2. I want you to pause this video and just look at this example that I have here and ask yourself, what do you notice and what do you wonder? Well, I notice that we have a trinomial, x squared plus 5x plus 6 is equal to the product of 2 binomials, right? X plus or minus blank times x plus or minus blank, right? So I notice that we have one trinomial on one side and 2 binomials on the other side of the equal sign. So basically what we're going to learn today is how to factor all types of trinomials, and in Level 2, we'll be working on factoring simple trinomials in the form of x squared plus bx plus c. So in order to do this, you want to find 2 numbers whose product is equal to the c value and whose sum is equal to the b value. So when I was teaching 9th grade, what I noticed is that when I taught this topic, many students struggled to find the 2 numbers that work sometimes because there is no specific formula to use to find these numbers. It is a lot of trial and error. Right, so I'm going to share with you a way to organize your work that I have found effective with my students that helps you kind of guarantee that you will eventually get to the 2 numbers that you're looking for as long as you persevere and you're not just stuck like driving yourself crazy trying to find the 2 numbers that work. So let's go back and take a look at the example from the beginning. We want to factor the trinomial x squared plus 5x plus 6. So basically, we need to find 2 numbers whose product is positive 6 and whose sum is positive 5. So what I always suggest my students to do is set up a table for yourself, a product of factors and a sum of factors table. So what you're going to ask yourself first is, what are 2 numbers that multiply to positive 6? What are 2 numbers that have a product of positive 6? So I'm going to start with 6 and 1, right? 6 times 1 is positive 6. So that works. And now let's add the two numbers together to see if we get positive 5. But 6 plus 1 is 7, so that's not what we're looking for, right? We want the two numbers to have a product of positive 6 and also a sum of positive 5. So now we'll try another two numbers. Let's try 2 and 3. 2 times 3 is 6, so that works. And 2 plus 3 is 5. So that also works. So that means positive 2 and positive 3 are the numbers that we're looking for. So when you factor x squared plus 5x plus 6, you get the sum of x and 2 times the sum of x and 3. So I want to talk about the right side of the equal sign for a second. So this is what we call the factored form, okay? When we express a quadratic as the product of two binomials, that is called the factored form, okay? On the left-hand side, that is called the standard form of a quadratic, right? So what we're doing is we're factoring a quadratic from standard form into factored form. And we would say that x plus 2 and x plus 3, right, or the sum of x and 2 and the sum of x and 3 are the factors, right? So the sum of x and 2 times the sum of x and 3, that's your factored form. And the sum of x and 2 and the sum of x and 3 are your factors. So taking a close look at what your signs of B and C are will help you find those two numbers, because the signs of B and C affect the signs of the factors. So if both B and C are positive, that means the signs of your factors are going to be positive, positive, right? Because a positive times a positive is a positive, and a positive plus a positive is a positive. If B is positive and C is negative, that means one factor is positive, one factor is negative. That's because if C is negative, that means we're trying to find two numbers who have a product of a negative number, right? And a positive times a negative is a negative. So the signs of the factors have to be positive, negative in this case. If B is negative and C is positive, then that means that the signs have to be negative, negative. And that's because a negative times a negative is a positive, but we want the sum to be negative, right? A negative plus a negative is going to be a negative. And lastly, if B and C are both negative, then that means our signs have to be positive, negative. And that's because, again, we want two numbers whose product is going to be negative. So that means we need to have a positive and a negative number. So now let's kick it up a notch. I have these two examples here. I want you to pause this video and ask yourself, how are these two the same but different? Well, you may have noticed that if you divide each term in the first example by 4, you'll get the second example. Or if you multiply each term in the second example by 4, you'll get the first example. So what do we do if we want to factor a trinomial in the form of number 1, right? Notice how now our leading coefficient is not 1 anymore, right? We have a value of a now. So how are we going to factor something like that? Well, first, you always want to look for a GCF, a greatest common factor. Hopefully you remember this concept from middle school, finding the greatest common factor. So we look at all three terms, right? 4x squared, 4x, and 120. And we think, what is the greatest common factor of all three terms? Find that first. the GCF is 4 here. A lot of the times with these questions, the greatest common factor is the actual leading coefficient. I can't guarantee you that that's always going to be the case, but what I find with these questions is that if there's a GCF, a lot of the times it is this leading coefficient. So try that first. So what we do with the GCF now is we're going to take it and we're going to divide each term of the trinomial by the GCF. Okay. Now we bring the GCF down because remember, we are factoring. We're not solving. So we're not just dividing by 4 and throwing it away. This is something I used to stress to my students all the time, is that they forget to bring the greatest common factor with them, right? We're factoring. The greatest common factor is a factor of this trinomial, okay? So we take the greatest common factor, we bring it down with us, and we open up a set of parentheses. And what's going to go inside is what's left after we divide each term by 4, right? So 4x squared divided by 4 is just x squared. 4x divided by 4 is x. And negative 120 divided by 4 is negative 30. We're not done yet though, right? We have to take a look at what is left inside the parentheses. Now, this is a simple trinomial, and we just learned how to factor that. So in order to factor completely, you first factor out the greatest common factor, and then you continue to factor until you cannot factor anymore. So bringing down the GCF again, I just set up my parentheses and filled in the variable. And now we have to find those two numbers that have a product of negative 30 and a sum of positive 1. So here's where you're going to set up your product of factors and sum of factors table to help you organize your work and make sure that you find those two numbers that you're looking for. So again, look at the signs, right? Our C value is negative. That means what? What does that mean? We just learned that. That means our factors are going to have to be positive, negative in order to get a product of a negative number. So let's try some out. Let's use 5 and negative 6. 5 times negative 6 is negative 30. So that works. It's a possibility. 5 plus negative 6 is negative 1. Well, we're not looking for negative 1. We're looking for positive 1. So here's a tip. If you end up with something like this, where the sum is close to the number that you're looking for, it's just the opposite sign. What you're going to do is you're going to take your two factors, positive 6 and negative 6, and you're just going to switch the signs, right? You're going to make the positive 5 negative 5 and the negative 6 positive 6. So negative 5 times 6 is negative 30. That works. And negative 5 plus 6 is positive 1. And that's what we're looking for. So we fill in our parentheses now with x minus 5 and x plus 6, right? And we get 4 times the difference of x and 5 and the sum of x and 6, right? So here is your factored form now. And now we have 3 factors. Our factors are 4, the difference of x and 5, and the sum of x and 6. Please pause this video and work on the lesson 1, level 2 problems in the workbook. Moving on to level 3, factor by grouping. So let's take a look at this trinomial here. 6x squared minus 7x minus 3. So the first thing you want to do is always look for the GCF. But just like in this case, sometimes there is not going to be a GCF, right? If you look at 6x squared, negative 7x, and negative 3, there is no GCF of those 3 terms. So when that's the case, what do? How do we factor? We do something called factor by grouping. So what we're going to do first is we're going to multiply A and C. So A, your A value here is positive 6, and your C value here is negative 3. So 6 times 3 is negative 18. This number here is going to become super important in the next step of factoring. So don't forget that the product of A and C is negative 18. Next, you're going to find two numbers whose product is AC and whose sum is B. So this step is very similar to the method that we learned of factoring simple trinomials, right? But this time, you're finding two numbers whose product is AC, not C. The product has to be AC, and whose sum is B. So remember, AC was negative 18, and B is negative 7. So at this point, you can set up your product of factors and sum of factors table. And through trial and error, you should find that the two numbers that work are 2 and negative 9, right? 2 times negative 9 is negative 18, and 2 plus negative 9 is negative 7. So now we're going to take the B term, negative 7, and we're going to split it up and rewrite it. We're going to rewrite it as positive 2x minus 9x. So we're going to rewrite the whole trinomial as a polynomial with 4 terms, and it's going to be 6x squared plus 2x minus 9x minus 3. Now the plus 2x and the minus 9x, just in case you can't see it, it's coming from these two numbers here, right? Here's our 2, that's becoming our coefficient here, and here's our negative 9, that's becoming our coefficient here. We're just rewriting negative 7x as positive 2x minus 9x, right? And we got those two numbers from step 2, okay? Now, here's where the grouping comes into play. You're going to split up the polynomial into 2 groups, right? The first group is going to be the first 2 terms. And what you're going to do is you're going to take the first 2 terms, 6x squared plus 2x, and you're going to factor those 2 terms, right? So what we can do is we can take out 2x because that's the greatest common factor and multiply it by 3x plus 1. Then your second group, negative 9x minus 3, you're going to factor that group. So here we can take out negative 3 and multiply it by 3x plus 1. And in your final step, you're going to rewrite everything. So take a look at step number 4, right? This is the information you're going to use to rewrite your polynomial. Both groups share 3x plus 1. So that's going to be one of your factors, right? Because they both have this factor in common. So we rewrite 3x plus 1. Now take a look at what's left. We have 2x here and negative 3 here. All you're going to do is take those 2 terms and put them together as 2x minus 3, and that's your second factor, right? So when you factor 6x squared minus 7x minus 3, you get 3x plus 1 times 2x minus 3. And that's your factored form of your quadratic. So there are some special factoring cases that you should know of and you should keep in mind. They're just these are rules that you can just memorize and remember. And if you see polynomials in these specific forms, you know to just use these rules. So first is the square of sum, right? If you have a polynomial in the form of a squared plus 2ab plus b squared, then your factored form is just going to be the sum of a and b squared. Square of difference, if you have a polynomial in the form of a squared minus 2ab plus b squared, then your factored form is going to be the difference of a and b squared. And the difference of squares, if you have a squared minus b squared, the factored form is the sum of a and b times the difference of a and b. So these three rules are just something that if you remember, if you see a polynomial in any of these forms, you really don't even have to think, just use the rule to factor them. Please pause this video and work on the Lesson 1, Level 3 questions in the workbook. After you finish the problems in the workbook, you can move on to the next video for Lesson 2.